common cathode 7-segment LED display, what you are seeing there, using Arduino, this new chip TM1638, and this is the board, how I linked everything. These are the segment pins that are going to these segment pads and are driving directly the segments of this LED display. It's using 3 signal wires, a clock wire, digital in-out, and CTB. And these 3 wires, I link them to pin 2, 7, and 11 here. Just not to make short if they are too close together. The negative wire of the chip is to the negative pin of the Arduino, so it's common negative, and the power is coming through these 2 alligators clip from that small little 5 volts 1 amp power supply adapter. Right now the program is driving only one single display. You can barely see it here, but it's here in the middle. This one is actually saying there G1, it means grid 1 is this one in the middle, and this line, if you're following it, is right in the middle there of the display. The chip is sending positive signal through this all segment lines, through here and through these long wires to all the segments. So right now I'm presenting only one single display running with the code from Arduino through this chip. So this is the 3D view of the circuit on the cardboard. We're using this TM1638. It's using 3 data wires, CTB, clock, and DO from these 3 pins, these 3 green wires from the right side. On the left side here, all the brown wires are the pin segment of the chip that are going to the pin segment of the display, and the display is flipped on the other side. As you can see, the markings segment A, B are reversed here on this side because here on this other side, this is the normal labeling here. You see A, B, C. So these pads are corresponding exactly with the pins of the display, and the pink wires that you are seeing here are the grid wires of the chip. They are going into the common wire of the display. Here for display 1, for display 2, 3, 4, and 5. In this case, I have 5 displays on this board. But the chip can drive 8 displays in total. And this is the positive pin of the chip, the negative pin of the chip. As you can see here, they are the same. I actually measured them with the multimeter set on continuity. And the ground and the ground pins are common internally. It's a single rail. Also the same for VCC, for this positive rail is also common, is the same rail inside. So it doesn't matter where you power it, it's doing the same thing. You don't have to power it from 2 different power sources or from 2 5 volts. It's only one is enough, because it's literally one wire inside for the positive rail and one single wire for the negative rail inside the chip. That's it for 3D view. So this is the display I'm using here, and this is the program that is driving currently only one single display in common cathode type that is receiving negative as a grid or common pin here in the middle of the display. All the segment signal wires are positive per each pin, positive, and etc. On my board, I didn't use 1 kilo or any kind of resistance because these chips, they can drive the display safely. I believe, I'm not super sure, maybe like 200 ohms resistor, a very small, almost insignificant value resistance you can add for protection. But so far, in all my tests I did, is working fine without any resistors. So I believe the chip is having inside some sort of resistance per each segment or per each grid, doesn't matter, at least one per pin. Or another explanation that I can think of is that the displays that I'm having, they have some sort of LED protection, and when they are powered from 5 volts, that protection is not letting them die so easily. I never test this chip with standalone LEDs. I only tested it with numerical displays like these ones. But the earlier experiments I had with 1640, when I put 1 kilo here on the common rail, the display didn't lit at all. So this 1 kilo was way too big of a resistive value for the display to actually lit up. And a couple of hundreds of ohms, I believe it will also dim the intensity of the LEDs. And again, this is the test program that you've seen running there, counting from 0 to 9 pretty much. And it's using this library. So this is the address on GitHub for this library. And you can download it from here, download as zip. You can extract the zip and add it here in this folder. Here is the actual library inside, TM1638 master. This is the actual library here that you are calling it from the program for this common cathode 7-segment display specifically. There is another one, library here, 1638 anode, is for common anode display, which I will do next, not now. And this is a test program. It doesn't do anything important. It's just for testing. Here are the pins that I put those wires you've seen on my board there, on pin 2, on pin 7, and on pin 11. And that's it about the program. So this is the datasheet for TM1638. And this is driving common cathode LED display section. This is how you have to link everything. This is the IC pin, the wire onto the pad, and from the pad to the LED inside the display, and then is surging through the grid wire. So this is the flow of the current, like this, then like this, like this.
All right, this is the setup with 5 common cathode displays, and they are showing 1, 2, 3, 4, 5 correctly on all of them. So the chip is driving them perfectly right now. They are receiving the correct signals per segments and per grids. So a very successful hardware circuit links. I have no errors on the wiring, pretty much. This is what I'm testing right now. All right, this is another test program. This program will count from 0 to 9 and then loop again. It's a very simple program. Its purpose is to test all the wirings, all the grids, all the segments from the chip to all 5 displays.